Hi, everyone. Thank you for taking the time to join us today. For those of you who don't know me, my name is Mike McGarrigan, Business Development Manager at Milestone Environmental Contracting. And I will be moderating today's fireside discussion on the thermal treatment of soil between Milestone's Josh Howardson and Iron Creek Group's Chad Belenky. Guys, thank you for joining and taking the time to chat today. We'd like to acknowledge that we have a great turnout today with people participating across the country. I want to thank you for joining us as we launch our second bi-monthly webinar, where we aim to provide a contractor's perspective, lessons learned, and experience on a variety of topics related to the environmental industry. We're excited to share, as part of our commitment to ESG, we have partnered with One Tree Planted, a nonprofit environmental charity on a mission of global reforestation. One Tree Planted is involved in tree planting projects across Canada, including supporting the replanting of wildfire damaged areas in BC and reforesting areas in Ontario to help restore watersheds and wildlife habitats. To support their initiatives, Milestone will be making a one-to-one donation to plant a single tree for each attendee participating in our live webinar today. Moving along, a couple of housekeeping items to cover before we start the Q&A. You will see a list of poll questions. We ask that you please take a moment to participate, as your feedback will guide future webinar topics. As well, for reference, we'll be providing links to some past thermal treatment projects that Milestone has completed. In addition, we ask that you take the time to share your feedback and propose questions on the Q&A function located on the right-hand side of your screen. We'll be sending out responses to your questions after the webinar is completed. Would note, if you encounter any technical issues, please use the chat feature on the right side of the screen. If the issue persists and cannot be resolved during the broadcast, we'll be sharing after the event. At this time, I would like to take a moment to acknowledge the land on which we are speaking from today. It is the traditional and unceded territory of the Coast Salish peoples, including the Kwantlen First Nation, the Stolo Nation, and the Katzie First Nation. Given that we are gathered on a virtual platform and people are calling in from various locations, I would like to also acknowledge from coast to coast to coast the ancestral and unceded territory of the Inuit, Métis, and First Nations people that we each call home. We do this to reaffirm our commitment and responsibility in improving relationships between nations and to improve our own understanding of local Indigenous peoples and their cultures. We thank them for allowing us to meet and learn today on their territory. Now, without further ado, let's get started with a quick bio of our speakers. Up first, Mr. Chad Belenky. Chad is the president of Iron Creek Group and is responsible for the overall management of the thermal technology business. Chad has been active in the environmental field since 1996, working on government, commercial, and resource industry sites throughout North America. With more than 26 years of experience managing a diverse portfolio of projects and businesses, he brings a broad range of environmental and management experience to Iron Creek. This includes extensive background in both soil and groundwater remediation, all phases of site reclamation, civil earthworks, property transfer activities, and project management. As one of the three founding partners of the business, Mr. Belenky has been integral in the evolution of Iron Creek's thermal soil remediation business and the deployment of technologies across the globe. Chad and the team at Iron Creek continue to focus on delivering value-added thermal soil remediation technologies to the environmental marketplace. Chad, I said this before, but thanks again for joining. That's a long list that we had there.
All right, thanks, Mike. I appreciate the intro.
Yeah, lots of experience. So thank you for joining today. So next up, we've got Josh Howardson. Josh is a project manager with Milestone with over 20 years of experience in the environmental contracting sector. He has led a wide variety of complex remediation projects, including site decommissioning, barrier wall installation, thermal desorption systems, chemical injection systems, contaminated soil excavation, shoring, landfill capping, sediment and lagoon remediation, building demolition, in situ remediation, and disposal of contaminated soils. lead and asbestos abatement, design builds, engineered water storage, treatment pond construction, and water treatment system operation. Josh's extensive technical, field, and project management experience has resulted in the successful completion of projects ranging from $5,000 to $40 million in value. His expertise has led to the successful completion of many projects ahead of schedule and on budget. Josh, again, thanks for joining today and being a part of this.
Thank you, Mike. It's good to see you.
Yeah, likewise. And to say you know a lot about all the different services we provide would be a bit of an understatement, but lots of experience there, and excited to have you share your experience as it relates to thermal treatment of soil today. So thank you.
Thank you.
Now, as we move forward, I know today's attendees didn't sign up to hear me talk this entire time, but before jumping in, I would like to recognize that the both of you collaborated together. So correct me if I'm wrong here, but on the 2021 Brownie Award-winning Marwell Tar Pits project, correct?
That is correct.
That is correct, Mike. Yes.
Excellent, excellent. So what I'm really excited to hear as we weave through all these questions and this dialogue today is more information about this. And for those watching right now, you can see some of the visual pictures that have been provided of that Marwell tar pit project. So please take a look, and we'll talk about this a bit more as we get going here. So, without further ado, folks, Josh, Chad, what do you think? Let's jump right in.
Sounds great, Mike.
Awesome. So look, guys, I've got a number of questions lined up for you. And the first one to go over, real simple. I'm going to lob this out there, Josh, maybe to you. Tell us what thermal treatment is.
Yeah, thanks, Mike. Thermal treatment is a remedial technique where we have solid materials that are heated to increase the mobility and facilitate the extraction of the organic compounds. So Chad will discuss a little bit what we can do with those extractions. I'll take it to you, Chad.
Yeah, you bet. So once the organic materials are desorbed from the thermal treatment, ultimately they can be cooled and condensed and collected for either reuse or disposal, or they can be thermally destroyed in a combustion system like a thermal oxidizer or an afterburner. So thermal is just a really robust treatment mechanism for treating organic contaminants in soils and sediments.
Okay, excellent. Well, see, that wasn't too bad, right? That was an easy one.
The icebreaker.
There we go. So a little more in depth here. Let's talk about why someone would choose thermal treatment over other remedial options when they're considering their site and the different options available to them.
Well, really, thermal treatment is one of the most reliable methods for treating impacted soils and sediments, in that it can handle a really broad range of organic contaminants, including really high concentrations of contaminants or impacts and heavily contaminated material. And it can be effective for all mineral soils, not just coarse texture, but a broad range of soil types. It can really provide all-weather capability along with guaranteed timelines and guaranteed endpoints for the treatment. So it really allows, the client or owner and the participating parties completing the work the ability to effectively plan the remediation work at any time of the year and know that you're going to reach a successful endpoint as part of that.
Yeah, and I think one thing, Chad, like on our end in Milestone here, we're always looking at the long-term liabilities for our clients. And we're always reviewing that aspect when we review different remedial techniques. So, and as many of us know, like in BC, landfills that are designed and are receiving this heavily contaminated hydrocarbon material are not in every jurisdiction. So therefore, thermal technology is a really good avenue to explore when we're in these kind of remote areas or in an area where we don't have a landfill to take that material.
Excellent. And that's an interesting segue into the next question here. You talk about different locations and remoteness and things like that. But, the next question I have for you folks is, what settings can it be used in? Let's dive into that a little bit.
Yeah, I think for the thermal technology, it's excellent when we're looking at these remote sites. These are sites that have logistical challenges where we may be barging or there may be ice roads. These challenges add a lot of financial pressure to the project. There's additional transportation costs, tipping fees, backfill that it needs to be brought in. So, treating the soil on site and returning it to where it came from works really well in these remote areas. Though it works well in remote areas, we have deployed it in urban areas as well. As you were talking, Mike, the Marwell Tar Pits project was right within the city of Whitehorse. We operated that project for just over a year. And during that time, we met all the local bylaws and worked it there. So it works well in an urban environment as well.
And Josh, just further to that, traditional thermal systems maybe haven't been quite as mobile, but just want to highlight that with today's technologies and specifically some of our enhanced thermal conduction mobile gear, it makes it possible to conduct these thermal operations in some very remote places. Whether it be accessed by aircraft or barge or ship, like ice roads, etc., like Josh had mentioned. So it opens up a new avenue to really deploy thermal across a variety of landscapes.
Excellent. Well, thanks for that, guys. And so the next sort of part to this, we've talked about location, we've talked about the different remoteness and areas. Let's dive into the types of contaminant groups that thermal treatment can actually treat.
Yeah, Mike. So in reality, thermal is applicable for most organic contaminants, including all types of hydrocarbons or polycyclic aromatic compounds, as well as PCBs or trichloroethylene, the TC compounds, and then of course the burgeoning market of PFAS and PFOA remediation. In addition, thermal can be used for some mercury remediation. But in reality, the low temperature thermal that we're discussing here today really doesn't get hot enough to mobilize any other trace metals during the treatment. So, mercury is kind of the limit for that in terms of thermal treatment of inorganics.
Okay, excellent. So we've talked about, what it can treat. What about situations where thermal treatment isn't necessarily a viable option or a suitable option?
Yeah, really, from our perspective, the thermal treatment is effective on mineral soils and a broad range at that. But where it's not effective is in pure organic soils, such as peat. And really what happens is you move away from the desorption process and it becomes more of a combustion process. So incineration, which is a completely different process. So although incineration may be an option for those types of soils, really the thermal desorption piece doesn't apply to straight peat or organic soils.
Okay, great. So moving along here, so we've talked about now the situations where it's not suitable. What are some of the things, we've decided, okay, thermal is potentially a great option for a site or a project. Now we go into regulations and what needs to be considered. Josh, maybe I'll flip over to you on this one to start, but, walk me through and the group through what regulations need to be considered.
Yeah, thanks, Mike. It really depends on the land that the facility is located on. Typically in Canada, we're dealing with federal or provincial jurisdictions. And the federal regulations for the operation of thermal systems really comes down to the discharges that are the most important consideration. As in the Marwell Tar Pit project, there really was no mechanism for the Yukon government to permit the ETC technology. So in consultation with the government governing bodies, we did apply for an LTF permit and an air emissions permit. And these permits essentially were giving, the regulating body a way to track the project and a way for the community to ask questions and engage. We found that was a really big aspect for it. Provincially, it can vary. Determining the factor is the has waste, is the material has waste or just waste. Under the has waste treatment, this requires an authorization under the has waste regulations, and these considerations can be pretty significant. There are certain exemptions for treatment facilities that are located on the same site as the contamination. So, having an ETC system set up can be a really good option for that. Waste discharge regulations apply for a range of permit conditions and are normally required. But from a regulatory perspective, having the treatment facility on the contaminated site is very practical for these short-term projects.
Mike, just further to Josh's comments, as we look outside of the Canadian jurisdictions, this thermal equipment has been permitted literally around the world. So, working in EPA jurisdictions like California, which, we all know kind of set the bar in terms of regulation development at times, and for a variety of contaminants throughout those jurisdictions, other places like Australia or Europe. So it really just comes down to, as Josh mentioned, the jurisdiction that you're working in. But in reality, in most cases, it's a function of just working within the existing discharge permitting, like Josh had indicated, for the air emissions, et cetera.
Okay, lots of considerations there to be had when thinking about it. So on a slightly different topic, we've talked about the considerations a little bit, but one thing we haven't touched upon yet is ESG considerations that come to mind when you're evaluating thermal treatment system. Chad, I throw it to you here. What are some of the considerations that come to mind here?
Yeah, there's a couple big ones, Mike. So I think we mentioned earlier, the ability to recycle the soil is huge. So you're essentially eliminating that liability and recycling the soil back to where it came from. But the second one that we've been working on here is the ability to actually recycle the contaminant energy load as part of our process for heating the material. So we're actually taking that contaminant, recycling it or upcycling it to a kind of a higher end use and using it as part of our process, ultimately eliminating some of the need for the fuel for our process and providing a better endpoint for the actual liability by destroying it and utilizing it.
Yeah, and I think that keeping it on site there, Chad, really does reduce our carbon footprint. Really, it takes a lot of trucks hauling the material off-site, the backfill production, the transportation of that backfill in, landfill construction, the operational cost that kind of has, and essentially also for the neighboring properties. There is not that increased truck traffic and things happening on site.
Yeah, and just speaking of carbon footprint, Josh, ultimately the impacts themselves do maintain a carbon footprint as well. So being able to apply that into the process helps shrink the kind of net carbon footprint overall.
Yeah, it's interesting you guys say about that, not only the material going offsite, but what backfill do you need? So, to save 2 trucks for 1 load, essentially, because you ultimately have to put something back. And then also you touch upon that infrastructure aspect, roads being destroyed or, getting worn out, things like that. So all things as part of that. So appreciate the insight there, guys. And so let's do a little shift here. We talked about Marwell. I'd like if we can sort of touch upon that one again a bit more here. So I'll just propose this question and, take it away. Josh, maybe on the first one here, but what sites have you used thermal treatment at?
Well, yeah, the most recent one we have taken on was the Marwell Tar project. And that was one that I found was a very challenging site because it did have very heavy-ended hydrocarbons with a glacial till type soil that was there and a variety of weather conditions. We were, in the summer months in plus 20, 30 degrees down to minus 40 in the winter. So it worked really well within those kind of avenues of having all the different weather conditions.
Yeah, certainly Marwell was a very challenging site. There was a high volume of free product tar. It literally would pump up from the ground as you were traveling across the site, very, very contaminated. I think that was shown in some of the slides that were presented earlier here in the presentation. In addition to some of the work that was completed at Marwell, obviously from our perspective, thermal's been completed successfully at a variety of sites. large portion of hydrocarbon, kind of conventional hydrocarbon remediation, whether it be oil and gas or, fuel storage or process related contaminated sites. As well, we've recently completed an explosives and PCB remediation. It was explosives residue from the manufacturing of artillery shells and ammunition for the U.S. military down in Ohio. A very successful project there. Some interesting remote ops, fly-in projects, etc., as well as successful PFAS remediation trials with both the U.S. Navy and the U.S. Air Force in conjunction with Jacobs or CH2M, doing some work in the U.S. on that. So,
excellent. And you touched upon PFAS there, so let's sort of talk about that. And let's talk about the lessons learned from some of the past projects, as including the ones where you did PFAS trials. Obviously, that's an important topic right now. It's one of those emerging contaminants that I wouldn't say are emerging anymore, as much as they're very much front and center for folks. So let's talk about that a little bit.
Yeah,
go ahead, Josh.
Yeah, I think one of the biggest lessons learned, I think we've noticed in a few of these types of projects, is really the community engagement and the engagement with the regulators. It's essential in these projects. It allows our team to educate the public and the regulators on the process and what things we've taken into effect to essentially ensure public safety. So it's that portion of the project. Once people understand what's happening and what the things are involved in it and how we can keep the public safe, it's essential.
Yeah, I think some of the other things that we've learned, obviously a thorough contamination characterization is required. And, chatting with Josh the other day, he brought up a really good point about, often technically we're focused on, the contaminants of concern, obviously, and how that applies in the thermal regime. But sometimes we've had this experience where, maybe some of the other elements of the soil haven't been tested, and once you choose thermal, start to present different management strategy requirements. So, it's important to get a complete characterization of the materials and make sure you know what's going to be going through the process and what you can expect in terms of an output, and that way you can effectively plan for any emissions controls or whatever you may need for the environment or the setting that you're working in. I think from a PFAS perspective, one of the takeaways, I think there was a lot of talk early on in the PFAS development, remediation strategies about low temperature thermal not being applicable for PFAS remediation. And certainly through our work with the U.S. military, we've shown that, as long as you can get to a temperature of about 350 Celsius, you can get into the desorption range of those PFAS, PFOA components. And right now, obviously there's a lot of work ongoing with regards to destruction efficiencies and analysis protocols for the analytical methodology for testing. There's a large, I think 3,500 plus type of PFAS components, and they're gradually working up methodology for those. So that's some of the lessons learned here. I think ongoing throughout the thermal industry is, post-treatment, what happens, how to test for it, et cetera.
One other thing to note there, Chad, too, and I saw it come up in the questions with the low temperature thermal absorption there. All of the projects we've used this on, we haven't seen any changes to the soil matrix there. The geotechnical properties of the soil with the treatment process that we use stays intact. So it actually still is works very well for geotechnical purposes.
Yeah, that's a great point, Josh.
Excellent point. Yeah, thanks for sharing and answering that question, Josh. So in the process, Josh, I'm gonna throw this to you. When's the best time to engage Milestone? When you're thinking about different projects and in this case, thermal treatment.
Yeah, Mike, with all projects, I think the earlier that you bring in the team, the better. One of the things Chad kind of just touched on in the last question there, but our ability to review the data and have those discussions with the regulators and really talk with the firms that are characterizing the site making sure that they are looking at all the contaminants of concern, not just the ones for the contaminated sites regulations there. The air emissions really do come into effect, and we need to ensure that we've characterized the site properly so that we can have safe operation while we're on site.
Excellent. Okay, great. Thanks for that, Josh. So, we'll get into a bit more of the nitty-gritty here, and we'll look at, and I'll propose the question to you, Chad, the process and the timing to mobilize a thermal treatment system. What's that look like?
Yeah, Mike. So from our perspective, our gear generally goes out on kind of standard highway transport loads. So within a few days, we can be on site and starting to put together our equipment and be receiving soil, easily within inside of a week. So it's just a function of transporting the gear and getting some of the base infrastructure set up at the site, whether it be, fuel storage or some of the base rails that we've set up, with our Quonset hut systems, et cetera. And then essentially receiving the soil and starting to build the treatment cells. So within a few days, generally, we can be on site and starting to process.
Excellent.
Yeah, based on that too, I think there'd probably be, within about a week of time of preparation of the site, ensuring that you have proper liners and different things put in place as well.
You bet.
Okay. So ground condition, soil type, what are the considerations there?
I think the construction of the treatment pad area, does require competent level ground. And it's the one thing that's nice about the ETC process, though, is the type of material that we look to treat doesn't need to be a really granular material. It works really well in the silts and clays, and I think Chad can add a little bit more, color to that comment there as well.
Yeah, you bet, Josh. So in reality, the ETC process is pretty robust with regards to soil types. You can basically, from the range of the coarse textured soils right through to the tightest clays. And it's kind of interesting in that you would think, some of the tighter clays would be harder to treat, but because the process is a conductively heating system, the tighter clays actually conduct heat more efficiently and therefore can heat up quicker than some of the coarse textured materials. So at the end of the day, like Josh mentioned earlier, if we've got a fairly level area to set up on, and we can start to process a broad range of soil types, and including frozen soils or rock material, etc.
Okay, excellent. Now, what about the pre-treatment material preparation? What are those requirements, Chad?
With the ETC, there really isn't much, Mike. So I know with some of the rotary equipment for thermal, you certainly need to do screening. There's just the residence time in the chambers, a much shorter time than we would have in our process. And so with that, you need to get particle size down as small as you can. With the ETCs, there really is no pre-treatment or pre-handling or screening. We can take, like I said, rock or frost lumps or industrial debris up to, 24-inch minus into the system and essentially conductively heat everything. And at the end of the day, post-treatment, everything comes clean. So eliminates, obviously some cost as well as some time. And it also, eliminates additional waste streams from having to segregate materials.
Excellent. Okay. Well, and you touched upon something there, and I'm going to sort of poke at that a bit further. So we talked about waste byproducts or reject materials generated. Are there any during the thermal treatment with the ETC process?
Yeah, so with the ETC, there is no reject generated. Like I mentioned, you're able to essentially process everything. From a waste generation or byproducts, really what you have is byproducts of combustion from the thermal destruction of the contaminants. Those are ultimately coming out of an afterburner or an oxidizer that are operated at, specific conditions with regards to residence time and temperatures to ensure that, you get a clean burn and proper destruction of the contaminant. But other than that, the ETC really has no reject waste stream or no third-party stream. So it's what goes in comes out clean and can be used at the site for backfill purposes.
Excellent. Okay. So you guys have mentioned a couple of times about emissions, and so let's go into that a little bit. Can we talk about what that looks like and how that's handled and just the process as a whole when we think about emissions?
Josh, did you want to maybe touch
Chad
on Marwell or?
Sure.
I'll throw it to Josh for Marwell, and then I can maybe speak to just some of the generic processes that go with that.
Yeah, I think with the Marwell tar pits project there, we did have a third-party consultant come in and do some SUMA canisters and check the emissions to ensure that we had guidelines to ensure the public safety and the safety of the workers on site. That continued throughout the process, where there was daily, even hourly checks of both the emission streams and the ambient air around the site.
Yeah, and I would say the Marwell site was a pretty extensive air emissions monitoring effort. In most cases, what typically happens is for these mobile projects is, a mass energy balance would be completed for the contaminants of concern and the fuel use that would be, applied as part of that process. And then ultimately, processed through whatever jurisdiction we're in, the air emissions or ambient air quality guidelines. And in general, with the type of throughputs that we're seeing in our process, we've been able to achieve, pretty reasonable air emissions permitting for a variety of contaminants in a variety of jurisdictions. Here in Alberta, where we're based, our mobile equipment's actually licensed under a code of practice, so we're able to, kind of turnkey carte blanche without specific air permitting within a range of contaminants, and that includes, pretty generic hydrocarbon treatment, et cetera. So it can really just depend on where you're at, Mike, and what you're treating. But in general, the destruction efficiencies are very high with the process, and you're able to meet some very stringent criteria, including, like I mentioned earlier, California, which is that's a tough nut.
Yeah, to say the least. Okay. And so just to reiterate one of the points that was brought up earlier, we talked about weather conditions and seasonality and stuff like that. Is there any real effect on the process that weather has?
Yeah, looking at that, Mike, the multi-seasons that we worked with, there didn't really seem to be an increased treatment time or any other options that happen with that. One thing that's really nice with the EPC is that it doesn't have a lot of moving parts as well. So, when it got really cold out, we didn't have downtime due to breakdowns and stuff like that. It's a pretty stagnant process. So it was more of the other equipment that we had on site and keeping that in an operational way.
Yeah, and further to that, really the thermal process is an all-weather, all-climate, all-season process, and that's one of the big benefits is being able to, effectively clean up these sites in any condition. Obviously here in Canada, especially in northern climates, or far south, of course, with frost conditions and so on, it can be challenging with some of the other technologies, and thermal really provides a way around that. And in some cases, we've had experiences where the logistics piece is easier to complete in frost conditions. So ice roads, ice bridges, winter access in, a variety of conditions allows us to get in and treat during a winter operational window where other technologies would really be handcuffed for that. And just further to Josh's point, in terms of the ambient conditions, they don't really have a huge effect on the process from our perspective. So in terms of, cold weather creating additional fuel use or so on, it's really pretty minimal in terms of the scale and effect.
Okay. One of the, I'm going to pause a second on the questions that I have for you guys, as one has come in that, is just asking more Ontario-based. Chad, you've got experience in projects in Ontario, correct? As it relates to this?
That's correct. Yeah.
Can you walk us through sort of any of that process at all?
Yeah, so really, in terms of the air emissions permitting is where things change in Ontario. There's like other jurisdictions, so there can be an ECA requirement or a certification required for the combustion process. That changes if you're on federal lands versus provincial jurisdiction, and those ECAs can be available, whether you try and achieve them with your own proprietary equipment or through third-party equipment as well. So there's a few ways to work through that.
Okay.
Obviously, Ontario, I think, has some soil management guidelines, et cetera, that also kind of lend itself to being able to recycle soils on site and so on.
Okay. Thanks for that. Appreciate it.
Yeah.
And for those asking questions, we will provide responses to those questions as well after the fact. And then I would also just re-highlight to everyone, the poll is open, so please get your responses in on that poll and all those poll questions, as we'll be tallying that up to see and guide ourselves for the next webinar process. So back to, I've only got a couple more questions here, guys, for you, to be quite honest with you. We're just mowing them down as we go here. So one of the big ones, though, really is, what is the footprint required for this process? Let's talk about that.
Yeah, so for the ETC equipment, really, it depends on how many units go to a site.
Okay.
So, a couple units might be in the neighborhood of like a 55 meter by 75 meter area to set up, or maybe 3 systems, which we deploy quite regularly, 75 by 75 meters. And those footprints, unlike a kind of a traditional thermal plant where everything needs to be connected, if there are some unique site conditions that, whether it be where you're excavating or some of your soil management or even just working around infrastructure, we can arrange those systems individually. They don't necessarily have to be all in a block. So there can be some flexibility in how that footprint is arranged. In addition to that, in certain sites, I know we had a project in the Yukon that was a fly-in site. And so we custom built some gear with a smaller footprint just to accommodate, both the logistics piece, but also the site setup. And so, although it alters your throughputs a little bit, we can be quite flexible in how we set up that gear and deploy it.
Excellent. Okay, that's great. And in those considerations throughout this process, one of the things, what fuel is used for the thermal process, anyways?
So for our systems, they're multi-fuel mic, and really what that means is, any of the normal kind of heating process fuels. And really what we're trying to do in our process is generate hot air to complete the conduction and then the desorption piece. So fuels ranging from, propane or natural gas, LNG, based natural gas or fuel gas in certain instances, right through to the liquid fuels, whether it be butane, diesel, recycled fuel oil. We've had some success lately, both economically and just energy-wise, utilizing recycled fuel oil as a component. We've also looked at some biomass, which is certainly a possibility in terms of generating the front-end heat for the process. So it can be quite diverse. One of the unique things about the ETC process is, as we start to see some of these green fuels come online, like hydrogen, it's really not a big shift for us to switch to a green fuel combustion. The essential ETC process stays the same. You're really just changing out the heating mechanism. So again, pretty versatile in terms of the types of fuels. And as I mentioned in the ESG portion, some of the contaminant that we desorb ultimately forms part of the energy process here too. So kind of capture it from all angles.
Excellent. Okay. And so the last question I have for you, and rather important, it surrounds the QA/QC aspect of things. So Josh, maybe I can flip to you, and then we can go over to Chad after.
Yeah, I think for the QA/QC, there's generally 2 things that we're monitoring the most, and we've talked about them a lot through this, but it's the air emissions monitoring that we're doing on site to ensure that we're keeping the safety of the site. The other one is we generally have a third-party consultant that will be sampling the soil and ensuring that we are meeting the targets for the site for the treatability of the soil. So we go through the stockpile sampling, ensure that we've hit the targets. If some of the soil does come back to be a little bit elevated, we can just put the Quonset back together, keep heating the soil, and we can kind of adjust the treatment time. And through that process, we will work with a third party.
Yeah, just on that note, Josh. So really, at the start of a project is where we really start to hone in on how much time is ultimately required for that treatment. And so, as part of that QA/QC, like Josh mentioned, third party or the technical consultant completing the sampling and analysis interpretation for the meeting the criteria. As we start to get a few batches under our belt at the site and correlate, some of the on-site data that we collect as part of the QA/QC, which includes, we have thermocouples embedded throughout the treatment cells, and obviously various process monitoring stages. And we, kind of try and integrate that data with the technical analytical that's been received, and really try and streamline the process to trim it out to where we're, maximizing the efficiencies that are happening at the site. And I just want to mention too, from an emissions monitoring standpoint, in a lot of cases, in most cases, in my experience, for our mobile process, we are operating without kind of a continuous monitoring requirement. There's a bunch of work that's done at the front end, including, mass energy balance and calculating out what that looks like in terms of outputs to the system. And then, we essentially work within operational conditions, maintaining the right temperatures in the afterburners or the oxidizer and the right residence time and those kind of things. And, there's visual indicators like opacity, which we really have very little opacity from this process. But most times it's more of a process control QA/QC as opposed to, kind of Summa canister monitoring or ambient air quality, or even, portable kind of external site monitors. I think that changes as you get into fixed facilities, maybe a little bit more, or, some extreme haz waste type things, and it'll depend on the jurisdiction. But by and large, a large part of our work is based on front end kind of emissions calculations, and then operating within, correct operating parameters.
Excellent. Well, guys, that's a wrap on the questions that I had. I want to take a moment to thank you both again for doing this today, and appreciate all the insight that you've provided. And before we close out the webinar today, just would like to ask everyone to head over to our website, take a look at the services heading, where you'll find a list of our services that Milestone provides across Canada from coast to coast to coast in support of the environmental industry. In addition, you'll find more details on several of our feature projects, including Marwell Tar Pit. And while you're there, sign up for our quarterly newsletter to keep up to date on the latest news coming out of Milestone, including upcoming webinars, services, and events. And lastly, in the coming days, we'll be sending out a short 2-minute survey via email to gather your feedback about today's webinar. We hope everyone enjoyed today's event and look forward to seeing you at the next webinar. Thank you, and stay safe, everyone.
Thanks, Mike. Thanks, everyone.